Hello and welcome back to our channel Artezmia for another video about electronics. In this episode we will improve our laser tripwire alarm in several aspects. We found that it was very difficult to focus the laser beams and the LDRs if they are all on the same board. So going against our original idea of an integral single board, we now have two boards, one with the alarm and one with the laser modules powered independently. We power our laser modules with a 5-volt phone charger and a micro USB cable. Our alarm board is powered with a 12-volt power adapter that has a barrel jack. We significantly reduced the size of our board, which is now 6 by 10 centimeters, the same size as our first board that was made out of an old CD, compared to our last board that was 11.5 by 14.5 centimeters. It's about 1/3 the size. Instead of stepping down from 12 volt to 5 volts across a resistor to power the flip-flop and the relays, we use a low dropout voltage regulator, or LDO, namely an HT7550A-1 that can handle up to 200 milliamps, which is more than what we need. Relays and flip-flop need about 80 milliamps. To switch on the flip-flop, we replaced the bipolar transistor, BJT, with an N-channel MOSFET transistor. Instead of applying a current to the base, we apply a voltage, which is a lot easier. Here's the diagram of our circuit. Red is 12 volts, green is for ground. All other colors are just to help follow the lines when there are wire crossings. The wiring of the 555 timer is the same as is in the previous videos, but we will repeat it for those who haven't watched the videos. Pin 1 to ground. Pin 2, high side, 2 LDRs in series, then to 12 volts. Low side, a 10K resistor to ground. Pin 4, shorted with pin 8, connected to 12 volts. Pin 5 to ground through a 10 nanofarad ceramics capacitor, not polarized. Pin 6 and pin 7 are shorted. The high side goes to a 1 megohm resistor, then to 12 volt, and the low side, a 100 microfarad 25 volts electrolytic capacitor, that is polarized, connected to ground. Pin 3 is the output pin, a 10K resistor to ground. On the high side we have a 100 ohm resistor to the gate of the 2N7000 MOSFET and a 5K resistor to the gate of a 2N2222 transistor, BJT. Collector of transistor and source of MOSFET are connected to ground. Drain of MOSFET connects to the low side of flip-flop circuit. Emitter of transistor connects to the negative side of the siren, the positive side being connected to pin 4 of the timer, 12 volts. In parallel with the siren, we have an optional LED and 470 ohm resistor. For the high side of the flip-flop and relays, we use an HT7550 voltage regulator. The middle pin is voltage in, connected to 12 volts. The right pin is voltage out, connected to the flip-flop circuit and relay modules on the high side. The left pin goes to ground through a 1N4007 diode. This diode has the purpose to offset the voltage drop across the MOSFET on the low side of the flip-flop, both being about 0.6 volts. As per the data sheet, we use a 10 microfarad 25 volt electrolytic capacitor between V in and ground and another one between V out and ground. A low capacitance of 4.7 microfarad 25 volts should also work. Here's a picture of the circuit, top side. Here's a picture of the circuit on the bottom side. Red wires are 12 volts and also the connection between the high side of flip-flop and high side of the relay modules, which is also the voltage out of the voltage regulators. Green wires are ground. We used colored wires instead of naked wires to avoid shorts, but the colors have no particular meaning except for white that connects the low side of the flip-flop to the low side of the relay module. For this circuit, I didn't make a KiCad diagram, I drew directly with Inkscape. I also made a prototype on a breadboard. Here's a clip of the breadboard circuit in action. Here are 3 clips showing the voltages of the relay module terminals when the alarm is triggered. First, the voltage between high and low sides of the relay. Now the voltage between one of the signals and the low side. Now the other signal and low side. Here's a clip showing we have 12 volts across the pins for the siren when the alarm is triggered. Here's a clip of our circuit on the bench. On the right is a little board having a micro USB socket and the 2 laser modules powered by a phone charger 5 volts. On the left is our board with the laser beams focused on the LDRs. Now I'll show a clip of the real thing in action. The laser is focused on the LDR. Actually, there's only one of the lasers focused, but this proves the point that you need both beams to be interrupted to trigger the alarm. Conclusion. This board does work. If there's one improvement that I would make is to replace the N-channel MOSFET and the diode between the voltage regulator and ground with a P-channel MOSFET on the high side of the voltage regulator. It would work just the same, but I would have the same ground for the relay module, the flip-flop, and the rest of the circuit, which would be nice. Another important point I'd like to make is about the quality of the solder. I'm a newbie in electronics. This is my 5th circuit and the 3rd video. I have still plenty to learn. At the beginning of making the board, I ran out of solder I picked up at the local hardware store, and that I have been using without thinking much of it. I had purchased 3 rolls of cheap solder on AliExpress. Don't do that. Buy good quality solder, even if it means paying more for it. I had a very hard time soldering, even at very high temperature. The joints wouldn't hold, I had to redo many of them, and the job looks terrible. You'll learn by experience. As I was finishing this project, I was all hyped up, thinking about making a few of these boards and install them in my house. But imagination never rests, and now I think there are 3 avenues I'd like to explore. 1. If I'm not at home, I'd like to know if an alarm was triggered, having a message sent to my phone. 2. This alarm has to be connected to a wall socket, and normally these are very accessible, so a burglar would have no difficulty whatsoever unplugging the alarm, and that's the end of it. The idea is to reduce power consumption, to be able to power the board with a battery and place the board in a place that would be very difficult to reach. 3. Lasers are nice, they look cool, but wouldn't it be better for the alarm to be invisible to the unsuspecting burglar? The answer is to use infrared lasers, but this solution brings up quite a few difficulties focusing the beam on an infrared sensor. Thank you for watching this video. Please leave comments below. If you found it interesting or even useful, please hit the like button and subscribe to our channel and stay tuned for more videos.